morning student. In the last lecture we have seen about the methods of preparation of aryl halides. Okay, so aryl halides, what is meant by aryl halides, or you can sometimes it is called haloarenes. When what is meant by haloarenes? The compound in which halogen atom is directly attached to aromatic hydrocarbons, then it is called haloarene, or sometimes it is called the aryl halides. So aryl halides are generally represented by ARX. हे आपण काल बघितलं होतं. त्यानंतर methods of preparation of aryl halides. So in that first method, so aryl halides are prepared from halogenation of aromatic compounds, or sometimes you can say it is the electrophilic substitution reaction. Okay, so in that, what are the benzene is undergoes chlorination in the presence of catalysts like FeCl3, but the reaction takes place in dark, so you will get the chlorobenzene from the benzene. Okay, so that point is remember here, the reaction should be takes place in dark, then and then you will get the chlorobenzene or bromobenzene. If the reaction takes place in presence of sunlight, then you will get the alkyl halides, not the aryl halides. That thing is important in the electrophilic substitution reaction. So next that is the aryl halides are prepared from aniline, or aryl halides are prepared from Sandman reaction. So in that reaction, what are the aniline is reacts with the diazotizing mixture. So that is nothing but the concentrated that is nothing but the NaNa2 plus HCl. So this is nothing but the nitrogen mixture. So you will get the diazonium salt, benzene diazonium salt. That benzene diazonium salt further reacts with cuprous chloride or cuprous bromide. So you will get the chlorobenzene or bromobenzene as a product. Sometimes if you want to prepare iodobenzene, then that benzene diazonium salt is reacts with Ki, that is potassium iodide. So you will get the iodobenzene. So that is the one of the method how to prepare aryl halides from aniline. Okay. In the next part of this haloarenes, so we will see the chemical properties of aryl halides. So what are the chemical properties? So in the chemical property, first we see there is a resonance effect. So due to that resonance effect, aryl halides generally shows nucleophilic substitution reaction, but it is a reacts less than the alkyl halides. So that point is important here. So in the next point, so that is nothing but the chemical properties of aryl halides. So chemical properties of aryl halides. Chemical properties of aryl halides. So in that, aryl halide shows nucleophilic substitution reaction lesser than the alkyl halides. aryl halides काय करतात बघा, nucleophilic substitution reaction दाखवणार आहे, पण त्याची रिएक्टिव्हिटी कशी असेल, लेस असेल as compared to alkyl halides. So why this happen here? Because in the case of aryl halides, so what are the halogen is directly bonded with the benzene. So that's why there is a resonating effect is present in the case of aryl halides, and due to that the nature of CX bond, or you can say the what are the CX bond is strong in the case of aryl halide as compared to alkyl halides. Okay, so that thing is important here. So aryl halides, so what about the order of nucleophilic substitution reaction? So nucleophilic substitution reaction, so in the first case we see the nucleophilic substitution reaction of nucleophilic substitution reaction. So in that alkyl halide shows faster nucleophilic substitution reaction than the aryl halides. बघा मला काय म्हणायचं इथं, aryl halides पेक्षा alkyl halides काय करतात, faster nucleophilic substitution reaction show करतात as compared to aryl halides. So why this happen here? Because there are the some reason. So what are the reason why the aryl halide shows less, or why the reactivity of aryl halide is less than the alkyl halides towards the nucleophilic substitution substitution reaction. So that the reason, that is the first reason. So there is a resonance effect in the aryl halides. So what is meant by resonance effect? So it is a delocalization of pi electrons. So when the delocalization of pi electrons is formed, there is a alternate single and double bond, or you can say the what are the lone pair, what are the atom, on that atom there is a lone pair and that atom is attached with the carbon carbon double bonded. So at that time there is a resonance form. So that is nothing but the resonance effect. So you can say it is a delocalization of pi electrons. So always resonance is formed in the case of alternate single double bond, or sometimes the lone pair containing atom at that atom or such atom is adjacent with the carbon carbon double bond. So that is nothing but the resonance effect. So here we see why the nucleophilic substitution reaction of alkyl halides are faster than the aryl halides, or why the alkyl halide shows faster nucleophilic substitution reaction than the aryl halides. So what is the reason here? That is a resonance effect. Okay, so let us consider here one aryl halides, that is nothing but the chlorobenzene, and you know that chlorobenzene, or you can take the any halogen. So on the halogen there are the 7 electrons in the outermost orbit, but from the 1 electron is in bonding with the carbon of this benzene. But what are the 6 electrons? They are in the form of lone pair. What are the 6 electrons? They are in the form of lone pair. But how many lone pairs here? 3 lone pair. Lone pair, pair म्हणजे जोडी. Electrons किती आहे? 6. पण pair किती झाल्या? 3 lone pair. So that lone pair, from the 3 lone pair, 1 lone pair is in resonance, or that are participate in the resonance with the benzene. So that's why the somewhat that CCl bond is stronger than CX bond. बघा, जर इथं मी असं कंपाऊंड घेतला CH3Cl, ओके, तर या केस मध्ये रेझोनन्स हा फॉर्म होणार नाही किंवा इथं रेझोनन्स इफेक्ट नाही. पण जर आपण एरोमॅटिक कंपाऊंड घेतला आणि एरोमॅटिक aryl halides घेतला, सो दॅट इज नथिंग बट द क्लोरोबेन्झीन, तर या केस मध्ये क्लोरीन वरचे जे इलेक्ट्रॉन्स आहे त्या इन रेझोनन्स मध्ये काय करताय? पार्टिसिपेट होताय. त्यामुळे इथला जो CCl बॉन्ड आहे तो कसा असणार आहे? स्ट्रॉंगर असणार आहे कंपेअर टू CH3Cl बॉन्ड. यामध्ये बघा, यामध्ये रेझोनन्स नाहीये, पण इथं तुम्हाला रेझोनन्स इफेक्ट बघायला मिळेल आणि तुम्हाला नेक्स्ट जे रेझोनेटिव्ह स्ट्रक्चर मिळेल त्यामध्ये काय असेल बघा. सो देयर इज अ डबल बॉन्ड कॅरेक्टर in the CX bond, or you can say the double bond character in the CCl bond. Baka. So here there is a double bond character. So what about the Cl? So Cl having the positive charge, because what are the lone pair is in resonance with the aromatic ring, and negative charge is present on the ortho position. So you know that there are the ortho para position. So this position is nothing but the ortho position. This position is the ortho position, this position is meta position, and this position is the para position. Again same thing here, this is a meta and this is a ortho position. Okay, so these are nothing but the position when the mono halides, or you can say the mono substituted benzene, then there is a ortho, meta and para. Okay, so there is a negative charge on the ortho position. Okay, so this negative charge is again resonance with the next double bond, so you will get the next resonating structure. And you know that the stability is depend on the number of resonating structure. So in that there are the 4 resonating structures. So that's why the chlorobenzene is more stable than the methyl chloride, and hence it shows less reactivity with the nucleophilic substitution reaction. Okay, so again here positive charge in the next case, this negative charge is again in the resonance with the next pi bond, and this pi bond get break here, and you will get the next structure. The structure is like that. Here negative charge, here Cl positive, and in the last case that negative charge again shifted here, and what are the charge on the Cl? It will get neutralized, and you will get the again chlorobenzene. But only only change in the position of the pi electron. So see the structure first and last. So what happened here? There is only change in the pi electrons, position of the pi electrons. What are the sigma electrons or sigma bond? They remains as it is. So this is nothing but the resonance, and you will get the four structure near about. So you will get the four structure. So this is the first, second, third, and fourth. So you will get the four structure in the resonance, and that's why what are the CCl bond? They are stronger than CCl bond in the methyl chloride. बघा क्लोरोबेन्झीन मधला जो CCl बॉन्ड आहे तो डबल बॉन्ड कॅरेक्टर शो करतो. इथं बघा, इथं तुम्हाला काय दिसेल? सो दिस इज नथिंग बट द डबल बॉन्ड कॅरेक्टर. सो डबल बॉन्ड कॅरेक्टर मुळे तो बॉन्ड कसा झाला? स्ट्रॉंग झाला. कशामध्ये? अराइल हॅलाइड्स मध्ये. पण इथं तसं काय डबल बॉन्ड कॅरेक्टर नाही. कशामध्ये? अल्काइल हॅलाइड मध्ये. ओके, सो दॅट्स व्हाय न्यूक्लियोफिलिक सबस्टिट्यूशन, the order of nucleophilic substitution reaction, alkyl halide shows faster compared to aryl halides. So that is the one reason. That is nothing but the resonance effect. So what is the second reason here? So the second reason here, that is nothing but the type of bond, or you can say the hybridization, or you can say the bond energy. आपण काय म्हणू शकतो? आपण bond energy, bond energies. बघा आता कोणाची बॉन्ड एनर्जी बघायची. सो लेट अस कन्सिडर हियर टू एग्जांपल. सो आय टेक हियर अगेन क्लोरोबेन्झीन, I take here again chlorobenzene, and the next one is the methyl chloride. So these are two examples. But in these two, one is aryl halides and another is the alkyl halides. And in that case, the bond length it should be 1.70 angstrom here. In the case of chlorobenzene, CCl bond length is 1.70 angstrom, and in the case of methyl chloride, CCl bond length is 1.77 angstrom. So which bond is having more length? So CCl bond in the CH3. Bond length कोणाची जास्त आहे? CH3Cl bond. आणि bond length कोणाची कमी आहे? CCl bond. That is a chlorobenzene मध्ये CCl bond ची length कमी आहे, मिथाइल क्लोराइड मध्ये CCl बॉन्डची लेंथ जास्त आहे. मला सांगा आता कोणाची लेंथ जास्त आहे? CCl ची. मग याची बॉन्ड एनर्जी कशी आहे? कमी. बॉन्ड एनर्जी कमी असेल तर तो हा बॉन्ड लवकर ब्रेक होईल. लवकर ब्रेक होतो म्हणजे काय? की तो लवकर न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन शो करेल. पण या केस मध्ये जर बघितलं तर याची बॉन्ड लेंथ पण शॉर्ट आहे. आणि अजून एक केस जर बघितली, सो हियर हायब्रिडायजेशन इज sp2, बट हियर हायब्रिडायजेशन इज sp3. So you know that if the carbon ion hybridization sp3, s character increases, electronegativity increases. So what are the polarity goes on decreases. पण हा कार्बन हा sp2 हायब्रिडाइज असल्यामुळे तो काय करेल? what are the electron density of from the chlorine, they attract towards us. So that's why the electronegative character goes on increases and the bond does not break easily. Okay, so that's why bond energy is more in the case of chlorobenzene. But in this case, CH3, that is a methyl group, it is a electron donating, so it does not attract the electron density towards us. So that's why it easily donates the electron density to the chlorine. So that's why the bond length is more here. Bond length is more, so bond energy is less. So among that two example, which having the more bond energy, that is the chlorobenzene having more bond energy than the methyl chloride. So that's why chlorobenzene having more bond energy, that is the CCl bond energy more. So that's why it is a reacts less, or it shows less nucleophilic substitution reaction compared to alkyl halides. So that is another reason. That is nothing but the bond energy. In the next case, third reason, so why aryl halide shows less nucleophilic substitution reaction or reacts less in case of nucleophilic substitution reaction compared to alkyl halides. The last reason, that is nothing but the nature of CX bond in the aryl halides. So you have already seen that in the case of alkyl halide there is the nature of CX bond. So similarly here, the third reason, that is nothing but the nature, or you can say the polarity of nature of CX bond in alkyl halides, in aryl halides. Nature of Cl bond in aryl halides. Okay, so in the nature you can say that which bond is polar, which bond is less polar. So that is nothing but the polarity of CX bond in case of aryl halides. So again let us see here. So I have already told you that so the nature of CX bond is depends on polarity. So here Cl bond, that is a CCl. Okay, so I take here directly example, that is nothing but the chlorobenzene, and in the case of chlorobenzene, what are the CCl bond length is short as compared to CH3, that is a CCl bond in case of methyl chloride. Okay, so let us see here which bond is a polar and which bond is a non-polar here. So again we write here the bond length, it should be 1.77 angstrom. In this case the bond length it should be 1.70 angstrom. Okay, so what about the polarity here? So you know that the carbon is here, the carbon is the sp2 hybridized again, and here carbon is a sp3 hybridized. So which carbon is more electronegative? So sp2 hybridized, because s character increases, electronegativity of that carbon goes on increases. So that's why this Cl, no doubt this Cl is electronegative, it pulls the electron density towards us. But what about this carbon? It also pull electron density. So that's why what is the resultant pulling force? It goes on decreases. But in this case, what are the CH3? It does not pull the electron density. So here always Cl pull the electron density towards us. So that's why here CCH3, or you can say the CCl bond in case of methyl chloride is more polar as compared to CCl bond in case of chlorobenzene. So polarity is more in this case, polarity less in this case. So that's why the dipole moment of this molecule is 1.69 dB. Dipole moment किती बघा 1.69 dB. But in the case of methyl chloride already आपण बघितली, तो dipole moment is 1.83 dB. मग कोणाची dipole moment जास्त आहे? मिथाइल क्लोराइड. मग मिथाइल क्लोराइड ची dipole moment क्लोरोबेन्झीन पेक्षा जास्त आहे. म्हणजे कोणता बॉन्ड हा मोर पोलर आहे? CCl बॉन्ड इन केस ऑफ मिथाइल क्लोराइड. कोणता बॉन्ड हा लेस पोलर आहे? CCl बॉन्ड इन केस ऑफ क्लोरोबेन्झीन. मग कोण लवकर ब्रेक होणार? दिस वन, कारण पोलर आहे. पोलर बॉन्ड असेल तर तो लवकर ब्रेक होतो. हा पण पोलर आहे, पण दोघांमध्ये जर कंपेअर केलं, सो CCl बॉन्ड इन केस ऑफ CH3Cl is more polar than the CCl bond in case of chlorobenzene. So that's why aryl halides shows less or shows slow nucleophilic substitution reaction than the alkyl halides. So this is the order of nucleophilic substitution reaction, that is alkyl halides shows faster nucleophilic substitution reaction than the aryl halides. Okay, so that is the reason why alkyl halide shows faster nucleophilic substitution reaction than the aryl halides. म्हणजे काय? aryl halides शक्यतो न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन दाखवत नाही. जरी दाखवले, जरी aryl halides न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन शो करत असेल, तर त्या केस मध्ये स्ट्रॉंग न्यूक्लियोफाइलची गरज असते. स्ट्रॉंग न्यूक्लियोफाइल असेल तरच तिथं aryl halides काय करणार आहे? न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन शो करणार आहे. ठीक आहे. अजून एक पॉइंट इथं लक्षात घ्या की इन केस ऑफ aryl halides it does not shows SN1 and SN2 mechanism. That point is important here. In case of aryl halides it does not shows SN1 or SN2 mechanism. बघा हे SN1 आणि SN2 mechanism शो करणार नाही. आता का SN1 mechanism शो करणार नाही त्याचा रिझन बघा. जर आपण इथं हॅलोजन ग्रुप जर काढला आणि बघा दिस इज अ हॅलोजन, आणि हॅलोजन ग्रुपला जर आपण रिमूव्ह केलं तर तो पॉझिटिव्ह चार्ज तयार होतो त्या बेंझिन रिंगवर. हे कधीच पॉसिबल नाही. ओके, हॅलोजन हा कधीच डायरेक्टली इथनं निघून जाणार नाही, आणि असा पॉझिटिव्ह चार्ज असलेली रिंग ही कधीच स्टेबल नसते. सो इट इज अ नॉट स्टेबल, नॉट फॉर्म. म्हणून SN1 मेकॅनिझमने ही रिएक्शन न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन कधीच होणार नाही. आता राहिला प्रश्न SN2 मेकॅनिझम. बघा आता जर न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन aryl halide शो करत असेल तर SN2 मेकॅनिझमने होईल का, ते आपल्याला इथं रिझन बघायचंय. पण SN2 मेकॅनिझम मध्ये काय होतं? ऑलवेज बॅक साइड अटॅक. आणि जर बॅक साइड अटॅक जर होत असेल तर SN2 मेकॅनिझम किंवा SN2 ने रिएक्शन होईल का, ते आपल्याला इथं बघायचं. आता बघा हॅलोजनला ऑलरेडी अटॅच कोण असणार आहे, फिनाइल रिंग किंवा फिनाइल सबस्टिट्यूटेड फिनाइल रिंग असणार आहे किंवा सबस्टिट्यूटेड बेन्झीन रिंग्स असणार आहे. तर या केस मध्ये हा जो बेन्झीन हा कसा आहे, बल्की आहे, बल्की ग्रुप आहे, त्यामुळे इथं बॅक साइड अटॅक हा पॉसिबल नसणार आहे, बॅक साइड अटॅक हा पॉसिबल नसणार आहे. आणि ऑलरेडी दिस कार्बन हॅविंग द, बघा आता कार्बन मध्ये अल्टरनेट सिंगल आणि डबल बॉन्ड आहे, तर त्यामुळे SN2 मेकॅनिझम इथं पॉसिबल नाहीये, बिकॉज व्हाट आर द फिनाइल और बेन्झीन सबस्टिट्यूटेड ग्रुप्स और अराइल ग्रुप्स अटॅच्ड टू द हॅलोजन, दे आर all in the bulky nature, so that's why backside attack not possible, backside attack not possible in the case of aryl halides. Okay, so that is one of the important point. So aryl halides does not show SN1 or SN2 mechanism. Okay, so that thing is important here. Next we will go through the directly its reaction. So you can say the chemical reactions of aryl halides. Okay, so बघा nature of CX bond मध्ये आपण 3 पॉइंट why the aryl halide shows less or slow nucleophilic substitution reaction than the alkyl halide, त्याचे रिझन मी तुम्हाला इथं सांगितले आहे. ओके, आता नेक्स्ट आपण जो पॉइंट बघणार आहे that is nothing but the nucleophilic substitution reaction. आता बघा सबस्टिट्यूशन रिएक्शन aryl halide शो करतो, पण त्यासाठी तुम्हाला कशाची गरज आहे, न्यूक्लियोफाइल. पण तो कसा असला पाहिजे, इट शुड बी स्ट्रॉंग, then the reaction takes place, otherwise reaction does not takes place. Okay, so the first reaction of alkyl halides, that is nothing but the nucleophilic substitution reaction of aryl halides. Okay, and in that first one, nucleophilic substitution reactions. आता बघा परत इथं नावात त्याचं मीनिंग आहे, व्हॉट इज इन बाय न्यूक्लियोफिलिक. सो देयर इज अ जनरेशन ऑफ न्यूक्लियोफाइल substitution, that is the halogen is replaced by other group or atom. So nucleophilic substitution reaction. Okay, so in that case what are the halogen is replaced by, बघा X, that is the halogen replaced by sometime there is a OH, sometime there is a cyanide, sometime you can replace that halogen by OCH3 group, that is a methoxy group. Okay, so that is the nothing but the nucleophilic substitution reaction. बघा आपल्याला कशाने रिप्लेसमेंट करायची आहे हे तर आपल्याला बघणं इम्पॉर्टंट आहे. ओके, सो that is nothing but the nucleophilic substitution reaction. त्याला काय म्हणायचं, nucleophilic substitution reaction. So in that case the first reaction, replacement of halogen by OH, that is a hydroxyl group. So that is the nucleophile here, OH. So that is the first reaction, replacement by OH group. कशाने replacement करायचं आता, OH group. So there is again simple thing here. So in the nucleophilic substitution reaction we take here chlorobenzene, and that chlorobenzene is reacts with the NaOH, but there is some reaction condition here. Okay, so it is a reacts with the NaOH, so it should be alcoholic, but there is a required temperature, so there is a required pressure, high pressure, then and then the reaction is possible, otherwise the reaction is not takes place, because in this case there is a need of the strong nucleophile, and then there is a reaction takes place. Okay, so what is the reaction here? When chlorobenzene reacts with strong nucleophile, that is the NaOH, at high temperature 613 Kelvin, and the pressure is near about 300 atm. किती प्रेशर ला रिएक्शन करायची आहे, 300 atm. So what are the shear is just replaced by OH, but before that there is one intermediate, so that is nothing but the sodium phenoxide, and after it is neutralized by acidic condition, so H plus, so you will get the finally that is your product, so that is nothing but the phenol. बघा आता Cl कशाने रिप्लेस केला? Cl is replaced by OH. पण कसा रिप्लेस झाला? When chlorobenzene is heated with NaOH at 613 Kelvin temperature and 300 atm pressure, so you will get the one intermediate, that is nothing but a sodium phenoxide, and you will get the final product, that is nothing but the phenol. So phenol is nothing but the aromatic compound, sometimes it is called carbolic acid. Okay, so what is the another name of phenol? Carbolic acid. So okay, so phenol is obtained from chlorobenzene by just nucleophilic substitution reaction, that is the chlorine is replaced by OH, so you will get the phenol. And what is the byproduct here? So there is a byproduct, that is nothing but the NaCl. So you will get the two types of you will get here NaCl. So that is your reaction. Okay, बघा nucleophilic substitution reaction करतोय, पण Cl कशाने रिप्लेस केला? Cl is replaced by OH. त्यासाठी काय घ्यायचं तर NaOH, पण टेम्परेचर किती घ्यायचं? 613 केल्विन, pressure 300 atm pressure, so you will get one intermediate and it is a hydrolyzed in the acidic condition, you will get the OH and OH in बघा OH कुठे मिळाला तुम्हाला? क्लोरीनच्या ठिकाणी OH मिळाला, त्याला काय म्हणायचं? phenol. Okay, so that is one of the reaction, so that is under the nucleophilic substitution reaction. Okay, next बघा आता replacement by CN group. आता काय करायचं बघा? replacement by cyanide. cyanide group ने आपल्याला काय करायचंय? replacement करायचं. मग बघा परत replacement करण्यासाठी काय करावं लागेल? तुम्हाला रिएक्शन करावं लागेल. बघा आता पहिला OH झाला, नंतर काय करायचा? replacement by cyano. cyanide ला काय म्हणायचं? cyano group. कशाने रिप्लेसमेंट करायचं आता? cyano group ने. बघा अगेन simple here, again you can take here chlorobenzene, that chlorobenzene is reacts with beta. So here chlorobenzene, so that chlorobenzene reacts with nucleophile, that is a Cl minus, but that Cl minus is given by sodium cyanide plus CuCl, that is a mixture. So that mixture gives the Cl minus, that is nothing but the nucleophile, and this reaction takes place at 473 Kelvin. 473 Kelvin, and there is a need of some pressure. So at that time, what are the Cl? It just replaced by, what are the Cl? It just replaced by cyanide, and you will get the cyanobenzene as a product. तुम्हाला product काय मिळणार आहे इथं? So you will get the cyanobenzene as a product, and what is the byproduct here? So you will get the byproduct CuCl. Okay, so that is a nucleophilic substitution reaction. Cyanobenzene. So it is again chlorobenzene. Chlorobenzene चा कन्वर्जन कशात झालं बघा? Chlorobenzene is converted into the cyanobenzene. पण कसं बघा? cyannucleophile कोणी दिला? NaCN आणि CuCN च्या मिक्सचर. So that is nothing but the CuCN. या दोघांच्या मिक्सचरने तुम्हाला काय दिला? Cn मायनस न्यूक्लियोफाइल दिला, आणि इथे अटॅक केला, Cl बाहेर पडला आणि तुम्हाला काय मिळालं? सायनोबेन्झीन. ओके, सो दिस इज द बी. नेक्स्ट वन, रिप्लेसमेंट बाय OCS3 means what are the halogen is replaced by methoxy group, so that is nothing but the replacement of halogen by OCS3. Okay, third reaction बघा, replacement by methoxy, or you can say the alkoxy, replacement by methoxy group. So methoxy, so you will get the ether, replacement by methoxy group. Methoxy म्हणजे काय? OCS3. Okay, so again the reaction, so this is the C1. Okay, again benzene, here Cl, that is nothing but the chlorobenzene. When that chlorobenzene is reacts with, when chlorobenzene is reacts with sodium methoxide, or you can general say sodium alkoxide. Okay, sodium chlorobenzene is reacts with sodium methoxide at temperature, so chlorobenzene is reacts with sodium methoxide at temperature 573 Kelvin. What is the temperature here? 573 Kelvin. and pressure, but there is a need of the catalyst, that is nothing but the copper salt. इथे तुम्हाला काय करायचं आहे, catalyst यूज करायचं आहे. So that catalyst nothing but the copper, and it is acts as a catalyst, and what are the Cl is replaced by OCS3. So at that time it is called the ether. Okay, and you will get the byproduct here, that is nothing but the NaCl. Okay, but from that you will get the ether, methyl phenyl ether. So that the name of compound, methyl phenyl ether. Okay, so this is the formation of ether. बरोबर आहे. आपण जसं विलियमसन सिंथेसिस मध्ये इथर प्रिपेअर केलंय, तसंच बघा अराईल हलाइड्स घेऊन आपण इथर प्रिपेअर करू शकतो. पण दिस इज नथिंग बट द एरोमॅटिक इथर. याला काय म्हणायचं, एरोमॅटिक इथर. So this is the chlorobenzene is converted into the methyl phenyl ether by simply reaction of chlorobenzene with sodium methoxide in the presence of copper salt, and there is a need of temperature 573 Kelvin in the presence of 573 Kelvin temperature, and there is a need of some pressure. So we will get the, that is the methoxybenzene. Sometimes it is called methyl phenyl ether. Okay. Next case, replacement by NH2 group, that is nothing but the amino. That is the last reaction. So replacement by amino group. So you know that amino NH2. जसं आपण अल्काइल हलाइड मध्ये केलं होतं बघा, की अल्काइल हलाइडची रिएक्शन आपण अल्कोहोलिक अमोनिया सोबत केली होती. तर त्या केस मध्ये काय झालं होतं, रिप्लेस झाला होता हॅलोजन. कशाने रिप्लेस झाला होता हॅलोजन, NH2 ग्रुपने. पण एरोमॅटिकच्या केस मध्ये थोडं वेगळी कंडिशन आहे बघा. सो हियर रिप्लेसमेंट बाय NH2 ग्रुप. कशाने रिप्लेस करायचं, NH2 ग्रुपने. Halogen is replaced by amino group. So again here I take chlorobenzene, so that chlorobenzene. Okay, so बघा हा chlorobenzene. परत आपण सगळ्या ठिकाणी chlorobenzene घेतोय न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन मध्ये. So that chlorobenzene is reacts with, okay, so chlorobenzene is reacts with ammonia. Chlorobenzene reacts with ammonia in the presence of Cu2O. Chlorobenzene is reacts with ammonia. So this is the cuprous oxide, and temperature here बघा, temperature पण आपल्याला घ्यावं लागेल. पण इथं प्रॉडक्ट काय मिळणार आहे, what are the Cl is replaced by, what are the Cl is replaced by, yes, NH2, and you will get the aniline. So what is the temperature condition here? So there is a need of the temperature 473 Kelvin. So there is a temperature 473 Kelvin. There is a need of pressure. Okay. So what is the byproduct here? CuCl. Byproduct काय मिळालं, CuCl. So for the balance, you can take here 2 times of, yes, 2 times of chlorobenzene. So you will get the 2 times of aniline here. So aniline 2 times of, you will take the 2 times of ammonia. Okay, and then you will get the required product. So that is nothing but the aniline. But what is the byproduct here? So byproduct here, cuprous chloride, and there is elimination of water. So here you will get the aniline. So that is the NH2. So it is called the aniline, and 2 times of Cl plus H2O. Okay, so what happened here? Only Cl is replaced by NH2, but there is a chlorobenzene is reacts with ammonia in the presence of cuprous oxide at temperature 473 Kelvin, and you will get the aniline. Okay, so this is about the nucleophilic substitution reaction, means replace by X is replaced by OH, Cl, that is cyanide, methoxy, and amino group. So that is nothing but the nucleophilic substitution reaction. Only these nucleophiles shows nucleophilic substitution reaction in the case of aryl halides. Other nucleophiles does not shows the reaction with the aryl halides because they are weak type of nucleophile. Okay, so this is about the nucleophilic substitution reaction in the case of aryl halides. Next one, that is the रिएक्शन ऑफ अराइल हलाइड्स विथ मेटल्स. ठीक आहे. आता बघा न्यूक्लियोफिलिक सबस्टिट्यूशनचा टाइप झालाय. जसं आपण अल्काइल हलाइड्स मध्ये बघितलं न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन, नंतर एलिमिनेशन बघितल्या, नंतर रिएक्शन विथ मेटल्स बघितलं. आता या केस मध्ये काय करणार आहे आपण, अराइल हलाइडच्या केस मध्ये न्यूक्लियोफिलिक सबस्टिट्यूशन रिएक्शन झाल्यानंतर रिएक्शन ऑफ अराइल हलाइड्स विथ मेटल्स. ओके, दॅट इज द सेकंड टाइप ऑफ रिएक्शन. त्यानंतर आपण इलेक्ट्रोफिलिक सबस्टिट्यूशन रिएक्शन कडे जाणार आहोत. ओके, तर यातले बघा सेकंड टाइप ऑफ रिएक्शन, that is nothing but the reaction with metals. So you know that metals, magnesium, sodium, these two metals shows the reaction with aryl halides as well as alkyl halides. Okay, so that is nothing but the second reaction, reaction of aryl halides, reaction of aryl halides with metals. Metals are good conductor of heat and electricity, you know very well. So we consider here two metals only. So there is a sodium, magnesium, sometimes we can take the lithium. So lithium is also shows the reaction with the aryl halides. Okay, but in your syllabus only two metals, that is the sodium and magnesium. Okay, so you know very well when the reaction of alkyl halide with the sodium, at that time the reaction is called, yes, when the reaction of alkyl halides with sodium metal, at that time the reaction is called Wurtz reaction, sometimes it is called the Wurtz synthesis. Okay, but in this case what are the aryl halides is reacts with the sodium metal, at that time it is called fitting reaction. It is called the fitting reaction. If the both the molecule of aryl halides are reacts with the sodium metal, at that time it is called the fitting reaction, and you will get the diaryl compound, or you can say the diaryl group. Okay, so what is the reaction? So in that case, first one, reaction with sodium, reaction with sodium metal, or you can say the Na metal. And you know very well sodium metal is highly reactive with the water, so that's why in the reaction condition there is a need of, yes, there is a need of solvent. That solvent is nothing but the dry ether. Okay, so this is one of the chlorobenzene. So I take here chlorobenzene. It is a reacts with the sodium metal, but there is a need of two molecules in the case of Wurtz reaction. So that's why I take here two molecules of chlorobenzene is reacts with sodium metal. Two molecules of chlorobenzene is reacts with sodium metal. So you will get here, but there is a need of solvent, that is nothing but the dry ether. तर इथे तुम्हाला काय मिळणार बघा, डायफिनाइल डायआराइल compound. So what are the one phenyl is fit with the another phenyl. So that's why such reaction is nothing but the fitting reaction. याला काय म्हणायचं, fitting. So such reaction is called fitting reaction, and you will get the diphenyl diaryl compound. Okay, and there is a byproduct two times of NaCl. Okay, so what is this reaction? When two molecules of chlorobenzene, so this is the chlorobenzene. When two molecules of chlorobenzene is reacts with sodium metal in the presence of dry ether as a solvent, so at that time you will get the diphenyl as a product, and such reaction is called fitting reaction. या reaction ला काय म्हणायचं, fitting reaction. When two molecules of aryl halides are reacts with the sodium metal, at that time it is called the fitting reaction. Fitting केव्हा म्हणायचं, two molecules of aryl halides. Two molecules of aryl halides जर सोडियम बरोबर रिएक्ट केले तरच त्याला म्हणायचं फिटिंग रिएक्शन. ओके, नेक्स्ट केस आपण बघू. when one molecule is aryl halide, बघा, when one molecule is aryl halides and another molecule is alkyl halides. One molecule is aryl halide and another molecule is alkyl halide. Okay, बघा आता इथे one molecule काय झाला, aryl halide, so that is nothing but the chlorobenzene, and another molecule is alkyl halide, so that is nothing but the methyl chloride. So you will get the product, no doubt. तुम्हाला इथे product मिळणार आहे. Again condition here? Dry ether. So dry ether. So what is the case here? So this here combine with the 2 times of sodium. So here also 2 times of sodium. So you will get 2 times of NaCl as a byproduct. But what happen in this case? What are the CH3 group is directly bonded with this phenyl group, and you will get the compound. That compound is called toluene, or sometimes it is called methyl benzene. त्याला काय म्हटलं आपण? toluene म्हणा किंवा त्याला methyl benzene म्हटलं तरी चालतं. And what is the byproduct here? 2 times of NaCl. Again, this is nothing but the Wurtz reaction, but it is called as Wurtz fitting reaction. It is called as Wurtz fitting reaction because there are the 2 alkyl halides. There are the 2 halogen derivative, but one is the chlorobenzene, that is one is the aryl halides, and another is the alkyl halides. So at that time, such reaction is called. At that time, such reaction is called Wurtz fitting or Wurtz coupling reaction. याला काय म्हणायचं? Wurtz fitting किंवा Wurtz coupling reaction. केव्हा म्हणणार? जेव्हा एक मॉलिक्यूल हा aryl halide असेल आणि एक मॉलिक्यूल हा alkyl halide असेल. At that time it is called Wurtz fitting reaction. Okay? So this is nothing but the reaction with metal. जसं आपण alkyl halide चे रिएक्शन बघितल्या त्याचप्रमाणे aryl halide सुद्धा रिएक्शन दाखवतात सोडियम बरोबर, आणि तुम्हाला काय मिळतं इथं? डायफिनाइल मिळतं. जेव्हा डायफिनाइल मिळणार आहे त्याला म्हणायचं फिटिंग रिएक्शन, पण जेव्हा टोल्युइन मिळणार आहे त्याला म्हणायचं Wurtz fitting reaction. That is the difference between fitting reaction and Wurtz fitting reaction. Okay? The next one, that is a reaction with magnesium metal. So you know that when alkyl halide is reacts with magnesium metal, you will get the Grignard reagent, that is alkyl magnesium halide. So similarly, aryl halide also shows a reaction with magnesium metal, and you will get the aryl magnesium halide. So that is nothing but the Grignard reagent. Okay, and such reaction is also called Grignard reaction. There is the next one, that is a B. Second reaction, that is the reaction with magnesium metal. Reaction with magnesium metal. Okay. So again, what is the reaction when aryl halide? Okay. So we see a general reaction. So aryl halide, that is X, is reacts with magnesium ribbon or magnesium metal. Magnesium it is in the form of ribbons. So that is called the magnesium ribbon. So magnesium ribbon or magnesium metal. Again there is a need of solvent, because again magnesium shows the reaction with the water. So that's why there is a need of solvent, dry ether. So you will get the product here. So what is the product here? Mg in between phenyl group and halogen, because magnesium is a divalent compound. Magnesium is a divalent atom, and that's why it forms the 2 bonds. One bond with the phenyl ring, another bond with the halogen, and in such case it is nothing but the phenyl magnesium halide. So phenyl magnesium halide, so it is called Grignard reagent. That is called the GR. त्याला काय म्हणायचं? Grignard reagent. Okay, that is the general reaction. So this is nothing but the aryl halides, or you can say the phenyl halides. याला phenyl म्हणतात. So this is nothing but the phenyl halides. Okay, so that is nothing but the reaction with magnesium metal. So you will get the phenyl magnesium halide. But there is a one drawback of this reaction. Only bromo or only halides of bromine and halides of iodide shows reaction in the presence of dry ether. But if you want to prepare phenyl magnesium chloride, so at that time there is a use of some different solvent. That solvent is nothing but the tetrahydrofuran. म्हणजे बघा मला काय म्हणायचंय, जर इथं आपण हॅलोजन म्हणजे बघा, so this is nothing but the bromobenzene. याची रिएक्शन जर आपण मॅग्नेशियम सोबत करत असाल तर इथं ड्राय इथर सॉल्व्हंट चालतं, ड्राय इथर तुम्ही घेऊ शकता आणि तुम्हाला इथं प्रॉडक्ट काय मिळणार आहे बघा, फिनाइल. सो दिस इज प्रॉडक्ट फिनाइल मॅग्नेशियम ब्रोमाइड. ओके, बट इफ यू वांट टू प्रिपेअर फिनाइल magnesium chloride, then there is a need of some different solvent. So here again I take here aryl chloride, that is a chlorobenzene. It is a reacts with magnesium, so at that time there is a need of some different solvent, that is nothing but the tetrahydrofuran, and then you will get here phenyl magnesium chloride, that is a Grignard reagent. Okay, so what is the THF here? So THF is nothing but the tetrahydrofuran. So what is mean by THF? Tetrahydrofuran. Okay, so the structure of tetrahydrofuran is like that. So there is a 4 carbon, so that's why it is called the tetrahydrofuran, and there is a oxygen. So this is called the tetrahydrofuran. So it is acts as a solvent. So this is about the THF, tetrahydrofuran. That is nothing but the solvent. हे बघा हे tetrahydrofuran झालं, याला म्हणायचं THF. हे काय काम करणार आहे, सॉल्व्हंटचं. पण कोणत्या केस मध्ये, जर तुम्ही क्लोरोबेन्झीनची जर रिएक्शन मॅग्नेशियम सोबत करत असाल तर तुम्हाला THF हे सॉल्व्हंट घेणं मस्ट आहे. तरच तुम्हाला इथं फिनाइल मॅग्नेशियम क्लोराइड हा काय मिळेल, ग्रिग्नार्ड रिएजंट मिळेल, फिनाइल मॅग्नेशियम क्लोराइड. Okay, so that is the one thing remember here. If you want to prepare phenyl magnesium chloride, then there is a need of the tetrahydrofuran as a solvent. And what about the other cases? So you want to prepare phenyl magnesium bromide or iodide, then you can simply take dry ether as a solvent. So that is the difference between the two solvents. So while in case of chlorobenzene you will take here tetrahydrofuran, but in case of bromobenzene or iodobenzene you can take the dry ether as a solvent. Okay, so that is nothing but the your reactions, that is the reactions with metals. And in this halogen there is a last reaction remaining only, that is nothing but the electrophilic substitution reaction. So that we will take in the next lecture. But what is your today homework? That point is important here. What is your today homework? So in the today homework you can first write the first question. Why aryl halides shows less nucleophilic substitution reaction? Why aryl halide shows less nucleophilic substitution reaction compared with than the alkyl halides, So that is one of the question. Why aryl halide shows less nucleophilic substitution reaction, or you can say the slow nucleophilic substitution reaction than the alkyl halides. Okay, question समजला. aryl halide हे nucleophilic substitution reaction slow किंवा less का दाखवता alkyl halide पेक्षा, याचं तुम्हाला रिझन मी 3 पॉइंट मध्ये सांगितलंय. नेक्स्ट बघा, आपल्याला सेकंड जो बघायचा आहे, रिएक्शन ऑफ aryl halides with sodium metal. Explain reaction of aryl halide with sodium metal. हे तुम्हाला काय करायचंय, एक्सप्लेन करायचंय. मग यामध्ये वर्ड्स फिटिंग रिएक्शन पण येणार आहे, फिटिंग रिएक्शन पण येणार आहे. ओके, आणि तिसरा क्वेश्चन असेल ये दोनों क्वेश्चन सफिशिएंट. Why aryl halide shows slow nucleophilic then the alkyl halides. Next one, reaction of aryl halide with sodium metal explain. Okay, so today we stop here. In the next lecture we will see about the electrophilic substitution reaction of aryl halides.